How's it going, everyone? Eulier Gonzalez here again in a new setup, as you can see here, in a more cheaper place. Because uh, even though that things didn't went well as I would like to, uh, from that experience, especially because I want to get into a particularly market niche using Vue, but because there is no that market, and also the software engineer or the software market is actually highly competitive and they need professionals in there, and I was somewhat slack, uh, but now from that experience I come up here and say, okay, so now I have to get this for real, okay, in a professional manner. Show commitment to this. From this word, you can take a look at the etymology of profession in etymology.com, where they describe from the Middle French, circa 12th century, that profession or profession was a word to those who take sacred vows to enter into a religion. And in this case, this is not a religion software. You can think of this, the pen, but at the end of the day, it is important that whatever you are doing, you must take sacred vows to this. You must do that in a professional way. You must commit to that. But in any case, um, even though, so what I have done in the past 9 months is to, well, now take a look at what is on demand in the market, even with my own experience as a software engineer, working primarily with Vue. And now what I have done is to improve my JavaScript knowledge by looking is at course like Frontend Master as a way to understand is the operating programming, the async nature, as well as the new features of the EX 6 and 7, all right? Uh, and then, well, how you can now develop and build production ready React applications. And lastly, here in today's video, we're going to take a look now at the React performance. So, uh, because of that, I'm going to make a quick recap here, not only on this course, but also is on the React Dev Docs here, specifically on the escape hatches, on that you might not need an effect, and the life cycle of the reactive effects, as well as to take a look at these three aspects of this. Right? Why this is important? Because uh, as you develop now React applications, and because I have helped them to migrate other companies from Vue to React, and that was quite interesting. So the idea here is that, especially, you need to improve your technical communications. Your analytical skills are something important. Your analytical thinking, how your thought process, as well as your technical communications. Hey, can I uh, can I implement based on your can I implement your approach based on your explanation, as well as some good practice, some engineering good practice, followed by soft skills like, hey, you are do you have patience with yourself? Do you are you are empathetic? And lastly but not least is the domain specific knowledge that you need to. So um, this is something interesting and beautiful, because now again, the whole I'm gonna make a quick recap of this course, of what we have learned so far, describe briefly what we went over to the React Learn section, and then finally jump into what we really care about, which is you may not need an effect in the lifecycle reactive effect. So the TLDR of this is a course taught by Steve Keening, head frontend engineer at Temporal, this open source tool that allow to run a durable execution environment, or it's a durable execution platform. So you can think of this pretty much like a Kubernetes to cover specific use cases. But in any case, the idea here is that because you want to write is, or the goal of this is to look at how you can now write is React components the most performance way, therefore more effective and efficient, faster React applications. For that, we need to take a look at the quick introduction here as a way to understand what are the things that we need to learn, especially if you're going to develop these React applications. So it's important to know how this mechanism works as a way to guarantee that, hey, you must now know how these things work. So when you encounter any problems along the way, well, you can now apply is the best practice to come up here, or to come over out of the other side. So by developing this tool set to identify is these performance issues, you can come up with this best practice. So because of that, we look at now a couple things here as a way to describe is the aspect of what are the things that you should take a look first, or this tool set, especially when you want to improve the React performance applications. First, take a look at the live side. If they are on production, good. Second, look at the component hierarchy and states. Start from there. Also, if that is not a problem, so take a look at now the memoization technique or the caching strategies as well. Also, how they are now loading things on, or how they are progressively loading things. So for example, using the suspense API, how they are working with that. And last but not least, if you're in a really pickle, how you can use the transition API as a way to now defer some, as a way to now is prioritize rendering. So this is something interesting. So because of that, we need to take a look now at, well, how React actually works. Okay. After all, React is a JavaScript framework that allows to write is our UI like a functions, JavaScript functions. We look at how can we import and export components, as well as, sorry. Yes, import and export components, as well as how can you import and export components? How can we use the GSX? What is a GSX? Which is a markup. It's a markup syntax that allows you to now connect is your HTML with the JavaScript using curly braces. How you can create conditional rendering using if, rendering list of elements, and the importance of using key as a way to notify React, hey, you know what, I would like you to keep track of this for performance optimizations, pretty much like you have a folder where a lot of file in there. So once you know what's going on there, so if someone actually remove or put if someone actually do something inside of this, remove or shuffle, and so you know what happened. And in the case of React, well, it can actually render that components much more efficient. Also, we look at how can we pass data to our components, and why React actually is so important. The concept of writing your components in a pure way. And what the concept of pure way also means is that pretty much like a mathematical function, you take an input, given the same input, you always return is the same output. Okay? Why is this? Because now this allows us to run in any JavaScript environment, whether it is the server. So given this particular component and then you pass some data, you can now render this HTML to serve dozens, hundreds, even millions of users. The other is that you can now establish caching mechanism or using built-in optimization techniques or built-in tools like use meme or use callbacks. Okay, and how from there another feature is that it allows you to safely stop the execution when the component is being rendering. Okay, and this component rendering means that the way how reacts to your component is in a tree data structure, like, which means is that, hey, well, this is just some data structure concepts or data structure concepts, how you can organize your data. I'm not gonna dive deep too much in there. I'm just going to mention that these data structures, it's pretty much like you have in a store, your backpack, fridge. Right now I don't have a fridge. I really love to have one. That doesn't matter. But a fridge, a a fridge, a backpack, or a drawer where you can put things specific for store things. For example, ice creams or fish in your fridge. Okay, or you can put this, let's say, lingerie, wild stuff in your drawer, and your Mac and keyboard, mouse in your backpack. So even though if you change the order, or if you put those items in different stores, you might not get the same desired outcomes that you want. So in any case, so we have array, hash map, linked list, double linked list. We have stack, which we have queues, trees, graph. Okay, and particularly the using is tree, under rendered tree. Okay, as a way to now you can look at how all of these components are represented. So you have now this visual mindset or this visualization. And the other is the tree dependency. The tree dependency is, well, all of this logic, reusable logic, that you're going to put in your React component as a way to now provide this interactivity that you're looking for. Interactivity that is the next step of the React docs. Adding interactivity by defining a function and stick to that onto a event listener, all right, in your HTML. And because most of the time our applications, we want to also show data, that's what we have states, a component memory. So this state or components memory that allow us to now remember things between re-renderings, and anytime you want to remember a thing or to update that thing, you update the state. When you do that inside of your event handlers, or your function handlers, okay, there are a couple of things that happen. First, that is the place where you can update your state, okay. Another is you can think. So when you're updating your states, React pass through a rendering mechanism. So this rendering mechanism that is made of 3 phases, you can pretty much think of like an assembly line, okay, that is passing for each one of the states as a way to produce an output, like a Ford assembly line or a motorcycle assembly line. It's actually very interesting this process. So you have the trigger, rendering, and commit. The trigger is now, hey, when this state update happen, it is what's called the initial render. It means at the root of the tree, or it was caused at the by a component or any of its ancestor that update the state. So the trigger render, the rendering phase is where now it's going to evaluate that. How so? If this was caused at the root element, so we're going to create all of these elements using the create element a function from React. If this was caused by a re-rendering, it will call that component function that trigger that state updates, evaluate all of its prop functions, states, store that to be used in the next function in the next phase, and then call that function or the output of that function, that component. If that contains more React components, it will now continuously call that in a recursive way until there is no more component. And in that process is when the VDOM is recreated. The VDOM is just a concept from the computer science as a way to now have the ideal representation of the UI in memory and keep sync with the real DOM. So this process is known as the reconciliation, and this is what allows developers to write declarative UI using React. So it means that you now tell React which state your UI you want to be, and then React match that UI state with the DOM. So instead of you having to manually grab the DOM, update its attributes, or passing is the event handler to that, now you're delegating all of the heavy lifting to the React. Again, it comes with some trade-off, anyways. But the thing that from React 16 is that now with that they come up with something called fibers. With fibers is just additional information that they add into this VDOM, okay? And the fiber, React fiber, is now the reconciliation engine that allows us to pause, start, or interrupt, pause, start, or resume a rendering. It also gives us this rendering prioritizations. So for example, now you can use transitions and use transition API, for example. Exactly, like use transition as one of them. You know, like use transition and use transition and what is it? What's the next one? Yeah, use transition and use defer value as well, and defer updating a part of the UI. So use transition, use defer value. So now you have this rendering prioritization as well as rendering concurrent rendering. Concurrent rendering using use transition. Concurrent rendering using use transition as a way to update the state without blocking the UI. Without blocking. Okay, that's quite interesting. Use transition. So concurrent rendering with use transition, or rendering prioritization with use defer value. You know, that's one of the cool stuff here. But again, Uh, and then in the commit phase is when now, um, yeah, in the commit phase is when now the the once if this was caused, uh, if this state change was caused by at the root element, it's going to now, on based on the previous step, because it created the DOM elements, now it's going to append all of the elements and show you the UI. If this was caused by a re-rendering, now it's going to apply only the bare minimum necessary DOM updates if there are difference between rendering. So it can be so subtle like attributes or event listener or the DOM itself or DOM node childs. Even though in the docs they actually, in the old docs in React 16, you can see that and how it's getting interesting and how finicky it is and how precise also is React by applying these updates. So in any case, uh, once the DOM, or once now React applies the necessary change to the DOM through the reconciliation phase, the browser detects those changes and then apply and then repaint your page. So every rendering, a state act as a snapshot. In other words, this is not. In other words, states are synchronous. State are asynchronous. It means that your state value updates will be in the next render, and you can think that React fixed your states inside of your event handler uh, within that rendering. That's why they call this state as a snapshot. I also look at how you can is now emit concurring state updates uh, inside of your event handlers using the state, and also how you can work with the previous state and move on and update that. Very particularly not common use case, as I mentioned in the docs, is for example uh, updating is a state giving an async operation. So for example, you're sending a lot of these orders or click orders, right? And then you want to process all of them in a series of state updates. Uh, so that's a good example. And also look at how can we update our objects in states, array in states, and with that, the TLDR of that is always return is a new state, one. And second is if you want to make your state update consist, your state update logic consist, you can use this IMER to make it like mutable syntax. Okay. And when it comes to updating objects, always return a new state, or updating arrays in a state, always return is a new array for that. How you can now insert elements into that at the top or at the bottom. Also, how you can now is remove element using the filter for that, and say, hey, I just want it to get me this new array without that element. Okay, so iterate through all of those elements and give me and give me only those whose ID those are whose ID are different from this. All right. And how we can now is when it comes to the Scrum or UI, how important is to find a way to manage your states, have a state structure. How can we now keep our state update logic maintainable and pass data to distinct components? So that's why first it's important to think of React on how exactly is to understand how to think UI state as state change. Okay, and that is, well, a concept that they borrow from the a concept borrow from uh, the UI designers. So, for example, when they have mocks, they create all of the different visual state, identify all the different visual state possible. Also, the uh, identify all the different visual state possible, uh, as well as uh, what trigger those state updates, and determine or represent. The keyword here is represent, which is something that in computer science they use all of this data structure as a way to see how they can represent things, and play with that. So it represents your UI state using, or represent those state using use states, avoiding unessential states, and then connect the event handlers to update your state. So once we have this particular mindset, especially when you're going to create your UIs, which is also something in we're going to talk about that later. Thinking in React, okay, as a way that, hey, the software developers and the people around this React product actually now is giving you a mindset of how you should create UIs, which is something that is being using in the at the industry. Okay, so you have now React, and also you have is the sorry, yeah, you have is how you can uh, think UI state, how you can think UI change as a state change, and then how you can now organize your state, giving a state structure. Okay, and I think this is something important here. As I'm gonna hit the brake here a little bit. I think this is something important because now this particular mindset, it will give you now how your UI should be built, okay, according to there, and how you should think in terms of building UI. All of this is in theory. The practice is completely different. But even though when you are going to create your UI, which is most of the times actually those elements are already created, this is the way of how you're going to create your UI elements, not only for small UI elements but also for bigger UIs, as well as now the as well as the way of how first how to organize your state, okay, or how to think UI state, as they mentioned here, okay, how to think, sorry, is that how to think about UI change. For example, a button from different colors, okay, a button, a checkbox, and then you can scale that up with a lot of things. But how to think your UI state here as state change, okay, and then how you can organize that using is this concept from the database engineer, that is the that is the normalization, that database normalization, as a way to, in our case, a way to structure our state is like, well, group state together, group related state together. Now, group related state together. avoid any contradictory state, avoid any redundant state. So if you can get this data from its proper from or from in another proper props, or if you can compute that, that's not an state, okay? Uh, and avoid duplicate state because they are hard to keep sync. And also uh, avoid deeply nested objects in your state because it becomes also hard to keep sync with that, to update that. And then we look at how you can now share that states across different components. And this is now thinking in React, okay? As a way to say, it's like, well, the way you can do that is by defining is where your state should live. And by doing that, you now that component owns that state, therefore they become is the source of truth of all of those components that need to access or interact with, okay? So on that topic, when you have that, uh, we also look at something that they call here as control or uncontrolled components. This is a term useful especially when you're going to design and describe is the React capability of this. Okay, what is the capability of the component and what is the design? Is if the information is the important information or is the driven information of this component is coming from its props, then it is called a a control component. It's a component that is flexible, that kind of thing. Yeah, it is a component that is flexible, okay? But if now the main information is driven by its states, this is known as a control component. Even though that this is not a technical and specific way to, yeah, this is not a technical specific it's not a technical term, but again, it's useful when it comes to design and describe what is the capability that this component will have. And I think that's very, very illustrative because once we're able to see this, which is part of the core of now how you can scale your components, build now more ambitious UI, for example, not only admin dashboard to manage radio stations or hospital records and that kind of thing, but also is that how you can now is how you can now is manage radio stations, admin dashboards, or chat UI application and that kind of thing. It is important to, especially when you're going to build this UI, you have the mock, you have the data, and then you start to break your UI into multiple components, into a components hierarchy. Okay. Again, this is a particular mindset. Then you create your static version of the React component, and you identify the minimal but complete UI. You identify the minimal states, but the minimal but UI complete state representation of your UI change, and that is, well, if this state, if this data is barely up, if this data barely changed, that's not a state. If this data can I get this data from its props or from its state, that's not a state. I can compute that state. You know, if I can compute that state, that's not a state. And if I get this data from its prop, that's not a state. So again, some conditions apply, but most of the time, according to their docs, is that, right? And then now you are going to because this is part of the thing that I also would like to build. So when you find the minimal but complete UI representation, exactly, but once you find the minimal but complete representation of the UI state, okay, now you need to identify where those states should live and add this inverse data flow, aka you're going to pass this state if the component needs to, as well as the handler, and then these lower components will go now to emit, or in that particular handler, in that particular event, is going to now is run that handler which update this state. Okay, so because this is the way of how now you can is not only think how UI state change as state change, how you can organize your states, as well as how you can share your state across different components, uh, because the way how now React uh, keep track of your state is per component, is because the way how React keep track your state is at the position in the render tree. This is something useful when it comes to reset your state or preserve your state. So by default, resetting your state is by default, if you have two components in the same position in the tree, React will preserve that state. If you have different components at the same position in the render tree, React will reset that state. If you want to reset the state with the same components at the same position, you either or render the component at different position, or use a key as a way to indicate to React, hey, this is a unique component. I want you to now, anytime you render this, this will be is a new state. I want you to reset the state for that. So why this is important? Because especially when you now need to react to more states, the more inputs a state needs to react, the more it makes sense to create is to use is a way of the more states. Okay, the more your states. Now that we look at how to think UI state as states change, and how you can organize your state structure, yeah, how you can organize your states, and then how you can now pass that state to all different components. How also it's important to think in terms of React as a way to say, hey, do we have the mock? Do we have the data? Yes. Let me now break that component, break down this UI, or break down that mockups into a components hierarchy, and then find them create a static version of that. Okay, find the minimal but complete representation of the UI state, of the UI state change. It means that, hey, is this data is going to is betterly is this data betterly changed over time? That's not an state. Is this data come from its prop? Usually that's not an state. If I can if you another thing is that if you get your data from its prop or from another state, if you consider that information that you're getting is from the props or from your state, usually that's not an state. Or if you can compute this data, okay, from it is props or from another state, that's definitely not an state. What left probably is an state. It's not guarantee, it's not certainty, but that's when you do that, now you uh, decide where exactly. Now you're going to decide where those states should live. Okay, identify where your state should live. Therefore, now those components will become the source of truth of other components. That's one of the reasons why we have, for example, Redux. Okay, these particular components and or these particular libraries as a way to now organize the state UI here. And what is the main problem they're trying to solve? That is, how can we now represent all of this UI state change, okay, and keep it maintainable, sync, and reliable. So, um, because of that, then all right. So now that you identify where this component should live, it is time to add this inverse dependency, which is when you're gonna pass the states and the event handler to the child component that it needs to. So I'm recap that again because this is the fundamental, especially if you want to build this scalable UI. Okay, and I get it why a lot of these companies actually are moving forward when they say, hey, I need you to do this for me. I need you to actually be capable of creating this and do that in the fastest way. Because pretty much when you go out to a market, if you want to buy some popcorns, potatoes, you want to buy is oatmeals, vegan, carnivorous, whatever. You know what you're looking for. So that market should be there, and they must provide you what you need to. So this is pretty much what the things is here, especially as you're now going to provide this as a service. Remember that one of the things that I learned here is that everything is a market, and you like it or not, we live in there. That's part of the human nature. This value exchange, and yeah, that's my reflection on that. But in any case, okay. So, you got it. All right. So, mm, mm, okay. So identify where your state should live. That's right. Uh, and then, well, add the inversion flow. We also look at how you can reset or preserve your states, which is great. And also, is that now how you can is uh, manage your state, because the more input that this state needs to react, whether it's computer or human inputs, the more it makes sense to find a way to make it maintainable. And that is using reducers, which is just a concept that comes from the array reduce, where you have now a collection of value that you're going to have an accumulator, and then you apply some transformation to that and get the accumulation part of that. So apply transformation and update the accumulator, apply transformation and update the accumulator, and so on and so forth. Then you get a single output of that. This is what also enable is this state of this series of state updates. So in any case, uh, so we look at reducers using this custom building hook, where the first parameter is when you define your reducer function, and inside of that you say, okay, now it's time to create this function that takes an state and an actions to apply is or to generate a new bit of a state, right? So inside of that you define a switch case, which is the way of how you can now is to organize a lot of these conditions or a lot of these type of actions that can be at that can be to update your state. If you pass anything different, throw I'm sorry throw an error. All right, so uh, in how now that makes sense, for example, if you're building a chat application or a small widget, okay, as a way to now reset the state and pass is the proper state to each one of these components. For example, you have a contact list and a chat, and how by clicking in each one of them you can actually is show the preserved state from that. So that's actually quite interesting. And also when it comes to now pass data down to these components, how we use is the props as a way to pass from parent to child and so on and so forth, and how now this is a problem known as the props drilling. Because if you have now a long change of components that are passing data to all of these distinct childs, the problem is that if one of those components removed from the DOM, let's say you hide, and this is perhaps some component that you don't want to show, that some widget you want to hide or remove from the DOM, giving a particular condition, you break the link. So to prevent this, so now you have this context, and context allow you to describe is to create a context which is represent. It doesn't have any information. It just represent is which context all those components can use, and which concept can use or consume from that, or provide in this case, which which context all the components can use or provide. So we also look so here you have now is the way of how you can define your context, okay. And I'm not going to explain that too much, because I'm going to do that when you want to scale your component, your state using reducer. That's when the fun part begins, and that is with your context, which is something that you can now make aware of a subtree about that data, right? About that data, okay. Now this is useful for small app level state. So for example, analytics, for example, user states or authorization, authentication, right? Or for theming. Also, the React router actually use context as a way to keep track of, to store this information in one centralized place, to now provide you at which position the URL, which URL the user is currently at, okay, when clicking an event here and there, or using the history API to do that, because well, routing and data fetching is not trivial. There is a reason why there are some dedicated libraries to that, and I'm going to explain that later as well. So now we have is the context, as well as when it comes to now managing more inputs to an state, or when it comes to manage more inputs from an state, how now you can is use reducer and the context. And there's some caveat here, because with context what happens is that React will re-render all the child components that use a specific context using the use context API, starting from the provider. That value change, and that's why you have now here, for example, optimization techniques, even though they mention here, okay, the context provider needs to be above of the use context, okay, and the previous and next values are compared with the object.is. A similar comparison with the use effect, the array of dependency. So skipping re-renderings with Mimo does not prevent the children receiving fresh context values. Skipping re-renders with Mimo does not prevent the children receive fresh context value. Skipping re-renderings with Mimo does not prevent the children receive fresh context value. And if they receive those fresh context value, therefore they are now okay. Okay. And use context. Now look for the closest, and that's another caveat here. So use context is looking for the closest context. So you better be careful here. Of course, if they have the same name, right? Use context, always look for the closest provider above the component that calls it. It searches upward and does not consider providers in the component from which you're calling use context. Updating data passed via context, like so. Specify fallback default value, and overriding a theme for that. Settings here. Wait, what? Optimizing re-rendering when passing objects and functions. Exactly. Optimizing context for a part of a tree. This is when now you can apply this thing. Exactly. It's like optimizing re-rendering when passing objects and functions. So one of the optimization techniques that you can use, especially using context as a way to pass down data to a subtree, is that by using using Mimo and callbacks. Okay, so for example, use Mimo as a way to compute a so use Mimo as a way to compute, usually in your entry point. Exactly. So use Mimo as a way to compute use Mimo as a way to only use Mimo as a way to skip re-renderings. Use Mimo as a way to skip re-renderings and only trigger that when the array dependency changed. And they do that by using is the object.is, which in contrast with double equality, where now JavaScript behind the scene actually do a type coercion. That's where you have this funky behavior, and a lot of people then decide to say, hey, no, let's going to use the triple equality. thanks to that. But again, in contrast with object.is, the triple equality doesn't check is the non not a number. So for example, if you have not a number and you want to compare that, for example, 0/0, right, or big int numbers, you don't, the triple equality actually fails, right? So that's what we have is the object.is. So, but in any case, the idea here is this. It's like, so now when you have, for example, this, when you want to save rendering here, okay? When you want to save renderings, yeah, when you want to skip re-renderings, use Mimo as a way to store now this calculation, this to compute this calculation, this state, and use callback as a way to skip re-renderings of functions reference, right? And then, only then, when those array of dependency change using the object.is, okay, now is when you want to update the value of the provider followed by the subtree. And I think this is something important, especially if you're handling analytics, if you're handling authentication, if you're handling is yeah, if you're handling analytics, if you're handling authentication, yeah, if you handle analytics, if you handle authentication, what's next? Theming as well. So now you put this small app level data that you want to only, when that update data changed, using, for example, a reducer instead of a use state, for example, or a reducer. Now you have a centralized place where you can know when this state updates, and this will give you a little bit more of certainty. So with that, then we look at how can we now, for example, handle cases where are outside of React, the escape hatches. Okay, so when it comes to control or synchronize to an external system, whether it is to control the focus of an input using the browser API, or to manipulate is the play and or to play and pause a video player implemented without React, for example, the video tag, or you want us to connect and receive and send message to a server. This escape hatches, or this way of how you can now, this is now the way of how React allows you to step outside of or interact, to sync and control external systems. They say now most of your application shouldn't rely on this logic. Most of your application logic and features should not. Most of your application logic and data flow should not rely on this feature, even though you like it or not. We do, especially if you're building this modern React application. Actually, that's what happened. Yeah, actually, that's what happened. Completely, man. Completely. So, so most of your application logic and data flow should not rely on this. However, because usually we need to connect to the external world with other servers, okay, a Python server or a Node, Java, so we need to interact with other systems. That's one of the reasons why the OC model exists, okay, this open open system interconnection, inter, open system interconnectivity. So the OC model here, you know, is the open system interconnectivity. That's right. Or open system intercommunication. Okay, because at the end of the day, that's exactly what this React. That's why JavaScript is now so popular here. Is that because allow us to now interact with other computers that are miles away from our position, uh, compute something and provide that for us. That's quite beautiful, totally. If you, a ver, let's see, a ver, let's see. So, if you, for example, in your cell phone, okay, when you get into your Google Maps, you want to say, hey, what will be the nearest restaurant in a country that I never visited before, which is Vietnam, okay? Oh, well, glad you asked. Here it is, you know. So you send that request, you communicate to another computer that actually contains the data and that information. It actually processes your query and then give it to you. And I think that's beautiful. That's also powerful as a humanity. As a humanity, that's also powerful because now we can. Let's see. Okay, not only centralize those data store in the in the hands of the small bunch people, but also we can now is have access and have access to data and therefore make better informed decision. This is pretty much what you can summarize all of this business. You get the data, and then based upon that, you take an informed decision. Useful if you live in countries with dictatorships or in countries where you don't have access to information, that kind of thing. Anyway, so yeah. Okay. Okay. All right. All right. All right. That's pretty good, by the way. That's pretty good. Cool. So, well, first we'll look at how you can remember things without re-rendering, okay, or without triggering a re-rendering using the useRef. So this is like a secret pocket where React doesn't keep track, and the main usage for this is for timeout IDs, something that I look at that. Yeah, for example, timeout IDs, or manipulating up some objects, some elements, or when you need to store some objects without when there is no required at rendering. Okay, when you don't need that rendering. So when this fits in the entire rendering mechanism, glad you asked, because the use ref is now defined before the commit phase and then assigned after the commit phase. And then I look at how you can now is communicate to external systems, which is now part of the core of this React application. The interactivity to other, not only to provide to the user, but also the ability to communicate with other systems. As a way to fetch data, for example, in a bank, you wanna send money to your mom, okay, and then you wanna do that and see your balance updated after that, okay. So you are communicating to an external system. So on that topic, right? Yeah, on that topic, all right. Yeah, on that topic. Okay. Yeah, so on that topic, okay. Um, mhm. So yeah, on that topic, okay, I look at now first is in React, okay. Um, yeah, in that topic, I look now that in React, especially using effects, we need to understand the difference between an event and an effect, and that is the logic in your components is split in two. You got now the rendering logic that must be pure. This is what you can use to compute derivative properties and the kind of thing. Uh, and also you have now the event logic, event handler logic. This is when you can perform these side effects. So use effect, the community or the React community say, well, let's go now to run this side effect code using the use effect uh, that are caused by rendering itself. And this will happen is at the end of the commit phase. After the screen, after the US screen is updated, now you're going to run this side effect, this piece of code. So we also look at when you don't need an effect, when you don't need to synchronize with external system, don't do this. And also how you can now create your own effect. Use effect from the React hooks that by default it will trigger this side effect codes after every commit phase. Most of the time we don't want to do that. That's why we have an array of dependency. If that is empty, it will indicate that this side effect will run only when the component is mounted, period. If you specify dependencies, okay, now it will enter in a particular phase, which is I'm going to now run this side effect after every commit, as long as the dependency change, okay, and then you have now the cleanup phase, which is usually when you're subscribing or unsubscribing, or you're connecting to disconnecting to an external system, you need this particular logic. So the way of how now the user effect works is that when your component is mounted, the setup code will be run. It means that at the user effect, the anatomy of the user effect is the first parameter is the setup code. Inside of your setup code, you define also your cleanup code, and the second argument, the second parameter is the array of dependency. So first you have the setup code that is being run when the component is mounted, and because now in React 18 they have a development mode, as a way we call as a strict mode, as a way to prevent is common gotchas in states and or in effects. The idea here is that well, mhm, yep. The idea here is that pa-pa-pa-pam. Mhm, mhm, mhm. Yep. So the idea here is to say now, uh, to describe now is how the effect works. Is the mechanism of the effects. So you have now when the component is mounted, you're going to run is the setup. Again, how now the effect works in development and in production, because in development you want to now have a particular behavior as a way to prevent some of the common gotchas in your states. in your hooks by re-rendering your component twice and uh, recall your components, your effect twice, okay? And instead of actually see how you can fix your effects to not run only once, to not how you can fix your how you can fix your code. hmm how you can fix your code, okay, how you can fix your code, how you can fix your codes to not run this component twice. Think of how you can fix your use effect logic to run with the cleanup function, to fix with cleanup function. So, because now in development, the way how this work is by running the setup, cleanup, setup, all right? In development, in production, is only run your setup code. So, when you are now developing this, the workflow of or the mechanism of the use effect is when the component is mounted, the it will run the setup code. If the when the component is mounted, it will run the setup code. If the re-renders, if there is a re-rendering, okay, uh, that cause to trigger the use effect, whether it's based on its array of dependency, or because it's now running after every commit phase, okay. Uh, so it will first, when the component is mounted, it appears on the screen. It will run the setup code. Uh, it will run now when the component is re-rendered without the dependency change. It won't run your setup code. When the component is when it is caused by a re-rendering and the dependency change using the object.is, now is when it's going to call first the cleanup function, and then the cleanup function with the old state, and then the uh, setup code. And the cleanup function will run the last time when the component is unmounted. So this, that might seem intrinsic nature of this, okay, is something that now it allows you, for example, to use your effect on this particular patterns. So, for example, controlling non-React widget, a map, a jQuery, okay. Uh, Also for animations, for subscribing events, for example, scroll events and for example, scroll events and the kind of thing. Uh, and the other is that for fetching data. So because there is no way to undo a network request, what React is doing using effect for fetching data is to use an ignore flag, okay, and on the setup code, if that flag is false, update that state. If it's true, now ignore that state. It means that do not update that state. So because of this is the way of how you can actually fetch data using effect, especially if you want to say, hey, I want you to run this when this component is mounted or when a props change, right? Because of that, in writing your component using effect is something that is manual, because now you have to deal is with these things. Your effect will not run on the server. It means that the server will pre-render the server on the initial server HTML is gonna be On the initial on the initial server rendering HTML, it's gonna send to the client. It's gonna show is the loading page. Now the client needs to download the JavaScript code to enable the interactivity, only to figuring out now that it needs to perform is a network request. That is inefficient. And the other is you now you have duplicate state. You have duplicate is network request, or this thing known as network waterfall. So it's a component actually is calling. It's a component is fetching data, and the child as well, and the grandchild, and the grandchild as well. So first, um, uh, fetching the more fetching data that this component exactly, the more fetching, the more data that a component or the more components need to fetch data, the more a waterfall effect is happening, therefore slowing down your app. And the other is that because there is no way to catch a response here, okay, because when the component is unmounted and mounted again, it's going to call that function, okay. And also to prevent some things like race conditions. When you're typing too fast, you are actually causing that kind of bugs. To solve these particular problems of, hey, this component is hey, this side effect is not running on the server, which is now you can do that in the most efficient way. Hey, now this is not now this side effect is running in cascade. You are now performing this network waterfall because each one of the components are doing that. Also, there is no ability to actually catch the data and to check that data if that stayed or not. So that's why React say, well, or you can use it as a framework, whether it is Remix, Next, sorry, Next or Remix, okay. Remix or Gatsby or yeah, that kind of thing. It's like, or you can use some client-side catching, or you can build your own. You can use a client-side catching like React Query, use the SWR or React Router, or you can build your own. But in that case, you will use an effect to add some logic to deduplicate requests, catching, and avoid network waterfall. Mm-hmm. Mm-hmm. The other is sending analytics. And when the sending analytics, you say, okay, or you set a flag to only run this for staging and skip the analytics environment, or to you set a flag for only run analytics on staging, not on development. Okay, that's why, for example, when you're building your API, it's something important to develop then by environment driven environment. You have your dev, you have your dev, you have staging and production. Okay, so that's why very illustrative, as well as you might not need an effect. Okay, so here is like updating a state based on a props or state. Don't need an state. Calculate, updating a state based on a props or a state. recalculate that at rendering time, catching expensive calculations. You can use this memo for that. Okay, exactly. And how to tell if a calculation is expensive? You use the console log time and console log time n as well. Resetting a state when a prop change. You don't need an effect. Use the key for that. Adjusting some state when a prop change. You either is define a state and then you compute that. Right? So for example, like this. Okay, adjusting some state when a prop change. So then you can now define a new state. For example, you define a state. Okay, you define a new state to adjust. Exactly. Okay, so based on, so adjusting some state when a prop change. Yeah, adjusting some state when a prop change. So for example, is that you define a state and then you need to calculate that. Okay, I want you to adjust some states when a prop change. Again, recomputing that. Sharing logic between handlers. It is better to have now one single place where you can now share that logic. Sharing logic between event handlers, sending post requests. Do not use an effect for that. In fact, it's use an event handler to do that. The other is change of computation. This might go a little bit beyond the scope of this. Okay, change of computations. Um, Sometimes you may feel tempted to change effect that just adjust a piece of a state based on another state. Okay, to adjust based on a piece of another state that. But again, use that. Okay, when a piece of a state needs to adjust to another piece of a state, uh, use an event handler for that. Mm-hmm. Okay, and changing change of computations. When a piece of state needs to another piece of state, okay, or when that adjust a piece of a state based on another state. When then you have this these state dependencies, chains of computations. Mm-hmm. When you have these chains of computation, it makes, of course, much more sense to do this. Mm-hmm. Chains of computation. Mm-hmm. Mm-hmm. Chains of computations. Mm-hmm. If you have an state that depends on another state, okay, or if you have a piece of states based on another state, okay, when you need to adjust a piece of a state based on another state, do that in the event handler or extract that into a function. This is a lot more efficient. Also, if you implement a way to view a game history, you now will be able to set each state variable and move to the past without triggering the effect change that adjusts every other value. If you need to reuse logic between several event handlers, when you need to reuse logic between several event handlers, extract into a function and call it from those handlers. Remember that inside event handlers, state inside of your event handlers, state behave like a snapshot. Okay, exactly. So for example, even after you call set round, the round variable will reflect the value at the time the user clicked the button. If you need to use the next value for calculations, define it manually like const next round is equal to round plus 1. In some cases, you can calculate the next stage directly in the event handler. For example, imagine form with multiple you can calculate the next state directly in the event handler. For example, imagine a form with multiple drop downs where the option of the next drop down depends on selected value of the previous. Then a chain of effect is appropriate because you are synchronizing with network. If you're synchronizing with network, initializing the application. In fact, when you want to initialize code, it's better to put that at every when you mount this component, when the application loads, or like this. Hey, I want you to now put this when the application runs or when there is a browser. Exactly. Hey, if this is the browser, all right, let me now run this piece of code. Go at the top level, run once when your component is imported, even if it doesn't end being rendered. To avoid slowdown or surprising behavior when importing arbitrary components, don't overuse this pattern. Keep app-wide initialization logic to root components model like app.js or in your application entry point. Notify parent components about state change. Let's say you're right. Okay. Notify parent components about state change. No. Inverse data flow. Inverse data flow. Notify parent components about state change. Notify that as your component. Exactly. Exactly. Inverse data flow. Passing data to the parent notifying parent components about state change, passing data to the parent. No, again, passing data to the parent. Parent need the same data. Let the parent component fetch the data and pass it down to the okay, exactly. Passing data to the parent. No, put the logic in the parent and then pass them to the child for that completely. And subscribing to external store. Sometimes your component may need to subscribe to some data outside of the React state. This data could be from a third-party library or built-in browser API. Since this data can change without React knowledge, you need to manually subscribe your components to it. This is often done with an effect. For example, subscribing to an external store. Your component may need to subscribe to some data outside of the React state. This data could be from a third-party library or built-in browser. Okay, to external store. Now you need to use an effect. Is that if you consume this data, or if you're going to consume this data from the third-party libraries for a built-in, of course, now it is time to use an effect for that. Not ideal manual store subscription in an effect. This is not ideal. Manual store subscription in an effect. Oh, this is manual store subscription. Manual store subscription to an effect. But for that, now they have this function to actually use that. Use external store. Subscribe. React won't resubscribe for as long as you pass the same function. Okay, because uh-huh. Mm-hmm. So React won't so React won't resubscribe as long as you pass the same function. Navigator.online, how to get the value on the client and how to get the value on the server. And this is now the setup and cleanup function. How to get the value on the client and how to get the value on the server. And when using is this, you are now subscribing to an external store. This approach is less error prone than manually sync mutable data to React state with an effect. Typically, you will write a hook like use online status above so that you don't need to repeat this code in the individual components. Read more about subscribing to external store from React components. Use sync external store. And the other is fetching data. Oh, no, many apps use effects to kick off data fetching. It's quite common to write data fetch like this, but you need to implement is the cleanup function as well, especially because most of your effect will fit in. Most of the effect you will write will fit into this category, okay, into these boxes that you have now on these baskets. So you have now is the on this basket. So you have now is the okay. 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 On this basket. So, and that is, well, connected to a non-React widgets or animation or subscribing to events or fetching data. And when you need to fetch data, it is important, especially if you're going to do that manually by your own. You should rely some. If you're going to do that manually, you need to set is the ignore flag, okay, as a way to now undo the network request. But you're not undoing; you are just ignoring is the previous request that you performed, and only take the last one. So even though that this particular feature or this particular code is um, quite problematic. First, because your side effects is not running on the server. The initial server HTML is sent to the client. The client now download the JavaScript. The client now show the loading page, download the JavaScript, only to figuring out that now it needs to perform is the fetch, right? So that's inefficient. So now you have this deduplication here. The other is that is there's if you have if a parent component and the child and grandchild actually calling making network requests, you have now this waterfall. You have this network waterfall, and also is you don't have the ability to catch requests here, because once the component is unmounted and remounted, you actually need to do that network request. So and also is it's not ergonomic because it performs all of these race conditions. You know, you have this issue with race condition. Because of that, that's why the docs say, hey, it's better to go with a framework implementation, whether it's Gatsby or Next or Remix, or implement your own, or use, for example, client-side catching like React Query, SWS see or implement your own, but after the end of the day, you need to create your effect. The must handle is the must is avoid the duplicated requests, must deal with catching and sorry a network and avoid network waterfall. Again, routing and data fetching is not a trivial thing. It's not a trivial. It's not a trivial thing. It is not. It is not a trivial thing. Oh my god. Holy moly. All right. Mm-hmm. Oh nigga. It is not like that. Mm-hmm. Okay. Okay. All right. Cool. 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 So here, one of the problems here is that you might not need an effect. You need is in this case is to paying is that ignore clause. Is that hey, if I'm going to fetch this data, if you want to implement that manually, I don't think that people actually do that, and to prevent any race conditions as well, is to prevent that. Is to say hey, this old data or this old network request, ignore that. And don't update the state there. And this issue applies to any UI library, not just React. Solving them is not trivial, which is why modern framework provide more efficient built-in data fetching mechanism that fetching data in effect. If you don't use framework and don't want to build your own, but you would like to make data fetching from effects more ergonomic, consider extracting your fetching logic into a custom hook. Consider extracting your fetching logic into a custom hook. Mm-hmm. Mm-hmm. Although this alone won't be as efficient as using framework building data fetching mechanism, moving data logic into a custom hook will make it easier to adopt an efficient data fetching strategy later. Okay. All right. All right. Okay. Let me take a break here quickly. Quick break here. Okay. So well, that'll be all for this video. Take care. Bye bye.